coffee.
Oh, okay, thank you. Hello everyone, thank you for coming today. My name is Jason Reinhardt.
Hi, and my name is Jun Hun. We come from Wentworth Institute of Technology from Worcester.
Yeah.
So for presentation today, we're going to go over why our products are outstanding compared with the products you see in the market. Also, we're going to show you how our design look like, and Jason is going to go over the hardware, software, and future improvements for our products.
Yep. So we did this project spanning 2 months of our freshman year, so last spring, for our Intro to Engineering Design class. Yep, so we're both electrical engineering
That's
majors.
because of it.
Yeah.
So you want to start with the engagement?
Yeah, I'll get my name straight. So I just want to start with a couple questions, just to see, get your brain going here. So think about something like this. So your living space, if someone were to try to break into it, how would they go about that? What's the easiest way to gain entry? And you just think about that to yourself and what measures you might take to help mitigate that risk. It's a scary thought, but as a freshman in college, we had 2 months to find some problem to address. And home security is kind of always an evolving sector. There's always new products, so there's always a problem to be solved. Every product has drawbacks and things that are good for it. So. Let's say that you removed all the technology from your house and you were given $100 and you had to somehow secure your house with that $100. What would you buy? What you might want to go, say like to Amazon, get a security camera, and that would be a good place to start. But do you trust the security camera? Do you know where all the data is going? And of course, you have to kind of trust it. If you use it, there's no other option. And so what we wanted to address in this project is we wanted something that is reliable, something that you can not spend a ton of money on, and that's something that you're in control of your data with. And so Trin's going to talk a little more about that.
Talking about the product you can buy from Amazon, just how much trust you put into that product, and what happens if the camera server go off, or the company who provided service to you go off while you're away from home. And that's also give us motivation to create a project that you can do with your own, and you can control the data the way it's sent to. So in the market right now, you can easily buy the home camera security with the range price around from 30 up to over $400, depend how many cameras you use, and depend on what type of technology that they use in those cameras. One of the common technology used in those sections for home camera security is AI, which is run on stream video in a real time to scan for people, vehicle, animals, or objects. So for AI products, they have a tier for low price. Those tier is not expensive, but also have limitation on the how it can detect the separate human and animal crossing or tree moving. For the high-end AI camera products, it seems like they can solve that problem, but also it's costly and so hard for you to install by yourself. And most of the time, it will involve with the monthly fee that you have to pay for the service to manage that that service for you, to contact the police when someone tries to break into your house. So both of them also raise a concern about privacy, where your video will go. Even some products they advertise like they have like in-home products that can store your video, so you don't have to send to the third party. But how much you know, like how can you trust it? Because you're not under control the product that you use. So that's why we create the products that you can create by yourself, which is reliable and cost effectiveness, simple installation, and also that's affordable home security automation. After 2 months we spent in introduction to engineering design class for freshman class, we end up finish our product. Sorry. To be able to finish this product, we need to enhance our skill in those areas with Python, which is, have a lot of open source online that we can learn by ourselves. We use Raspberry Pi. Soldering skill, we soldering a lot, and circuit analysis. We did a lot of troubleshooting about circuit analysis. Also, we improved the skill to use basic TCP networking. When you have our product gonna have 2 components, 2 boxes, and we try to make them communicate to each other. That's why we need the skill in TCP networking. Also, Fusion 360 is helped a lot to model how our product look like. And the 3D printing, it did an amazing job to help us put all of our idea and components into a house. And we feel like so good with our product when we make it, and I hope that you're gonna feel the same way I feel in the next couple of minutes when I get a chance to show our products to you. And this is our final design for our product. This is the front of the control box. It's gonna be mounted on the wall, and you can see it includes a screen, some user interface, different angle of the product. Back side. And this is the look inside the products that we have the Raspberry Pi in the end, and then behind right here. Then this is our box for the sensor box that you gonna mouse high on the ceiling. Either you can use inside or outside. Inside look of the sensor products, we have the sensor this area. We have the particle photon here. Different angle for you to see. And then underneath here we have 2 buck converter to provide stable voltage for our product. And Jason gonna talk more about that in the next couple slides. So now Jason gonna go over the hardware and software section. While he doing the presentation, I'm gonna just show our product to you, so you can just listen to him, and also you can touch and feel our products. I also have some alcohol wrap inside the box if you wanna clean it before.
Thanks, Trin. So these are the parts that we selected. If you wanted to put this thing together yourself, you're gonna need all these parts, and then so we're gonna pass around the model. It's purposefully open on the inside so that you can carefully open it up, see the wires, see the soldering, the process that was involved. So for the control panel, we chose a Raspberry Pi 3. It costed us around $35, and that's the most expensive part of the whole project. All the other parts of the control panel are less than $5. you know, that screen is around $2. The switch is 10 cents. Same with the buzzer. It's very, very, very cheap to scale up if we wanted. And so each sensor consists of a particle photon microcontroller, which is almost exactly just an Arduino with Wi-Fi. You use it, you code it with Arduino code, except it has some functions for Wi-Fi. So it was really helpful to have this over Wi-Fi so we can have the two communicate. Also on the bottom right here, oh, wrong button. Yeah, so on the bottom right here, there's the radar sensor. This is the centerpiece of our project. This is $2, and you can have as many of these as you want. So let's say you have like a big house, or just you want a lot of security in every angle of your house. You can have 6 sensors, 10 sensors. There's really no limitation. We've tried it with multiple, and there's no bottleneck of any kind. So also we have these 2 power converters here. It turns out the sensor, the radar sensor, is very sensitive, and it's funny because we were wondering why the sensor was on all the time. It was triggering high all the time, even though there was no movement. It turns out the circuits need to be separated between the microcontroller and the sensor. That way, we can have the voltage be very stable, and the sensor will be able to operate smoothly. So for the software, this is mainly using Python on a Raspberry Pi. And for the sensor, we're using Arduino code, but that code was very short. So pretty much when there's movement, the sensor will send a TCP packet to the control panel. The control panel acknowledges that packet and sends an acknowledgement to the sensor saying, hey, I got it, we're all good. If it doesn't get that acknowledgement, the sensor will keep sending the data until it's received by the control panel. So in events where there's a lot of network congestion, or you're in the city and there's a lot of interference, it might take a second, but it's gonna keep trying very quickly until the packet is received. And so that's really where multi-threading in Python really helps us out, because multi-threading allows you to run multiple loops of code simultaneously. So for those of you who have ever done programming, you would know pretty quickly that there's almost like a cursor when they're executing the code. There's a cursor, and as lines are executed one by one, and if you have a print and then maybe a sleep right after that, and then another print, it's waiting at that sleep, and you're not going to get the 2 prints to happen at the same time. With threading, you can create live objects, and you can have multiple loops going at the same time. And that allows us to do multiple things at once. We can check the buttons for pressing the buttons. We can check for incoming packets. We can check to see whether or not we need to buzz the buzzer, the speaker. So multi-threading is really helpful, and there's a ton of documentation about it. It's probably one of the single greatest features that Python has to offer, especially on such a small board. And we talked, about TCP networking. It's just a very basic form of communication over Wi-Fi. We just needed some way for the devices to communicate without the customer having to go and buy a whole new wireless infrastructure for their security system. In hardware I/O, that's another component of our software. This is how the Raspberry Pi communicates with the different components we selected. You know, the buzzer, the buttons, the switch, the LED. This is all controlled with GPIO, read and write, which is why people use the Raspberry Pi, so that you can read and write data on the many pins that it has. And everything is running on Raspberry Pi OS. We use what comes with the Pi, what is meant to be run on the Pi, and we put our Python code on that operating system. It runs it on boot when the Pi turns on. Here's the circuit, the schematic for a visual schematic for the endpoint. So each sensor might look a little bit intimidating, but really, there's not many wires, not many solder points. We're not using many of the pins on the microcontroller because what it's doing is very basic. When the sensor detects movement, this is the sensor here. When it detects movement, it puts out a high signal. And when a high signal is received by the particle, it sends out a packet over TCP. And then it waits. It waits until the sensor goes off, and then once the sensor goes off, it sends another packet for an on. And those packets are always checked to make sure that they're received. These are the power converters I was just talking about. So they separate the voltages. So if there's a lot of noise in one side, the other side is nice and smooth, and that allows the sensor to work while these digital computers is causing a ton of interference over its power lines because it's just switching on and off things. That's one of the biggest issues we had, because we noticed this issue. We tried an Arduino, we tried a Raspberry Pi, and we tried the particle photon. Every single little computer we were trying was causing that sensor to act really weird. It was always reading on, and that was what the heck is going on? It works when we plug it in on its own. So it turned out we needed separate voltage. And here's the schematic for the control panel. It's got a screen right there, a 16 by 2 character screen, an I2C bus adapter. So this is going to let us take all these 16 wires and only use 4 of them with the Pi, which is really helpful. We also had some issues with the screen. This I2C bus adapter solved that, making things simpler. And here's our I/O here. It's buttons, buzzer, LED, and it's powered with 5 volts over USB. So everything together, you want to make this yourself, it costs $67.90, give or take a little with today's market conditions. Yeah, and the reason why we're able to keep it so cheap is because we buy the parts ourselves, we solder it, we write the code, which now that the code is written, it can be mass produced, it can be duplicated easily. We have already done the hard part of designing the original circuit. Now we can make multiple. And the 3D printing is very cheap. 3D printers, if you want to get one yourself, like $200, it gets you one that costed like $2,000 like 5 years ago. It's really gotten a lot better. So it's fun. It's really fun to hold something in your hand that you just spent like 12 hours on a computer making.
Can I talk a little bit more?
Yeah, absolutely.
So the price, 67, like almost $68, is already include the power supply. We got it very cheap for $5 each. We use the power supply, the power bank, just in case that we out the power from the house. So we have enough power to power our products. So if you subtract like $10 from 2 power supply, that's one, it just costs like $58. And we also, you can have opportunity to add multiple sensors because our control box can work with multiple sensors. We're working on that one, but it's possible to do it. So we calculate around $26 for each sensor box.
Mm-hmm.
So if you want to add one more, it should be like another $26, $25 more for the price. But be positive that the price is going to go much down when we produce in mass, like we make it commercial. Because this whole thing, we have the project and the product in the time that we have a lot of trouble with the supply with the chip for the homework. So some of our product we have to use the old one because we can't get the brand new one on time for our class. So that's why we bought from eBay. And but that's helped a lot. We detect the problem with the old one. So.
Yeah, and using the older Pi, I mean the Pi is still, the 3B just came out in I think 2017, but it doesn't get so hot as the newer ones. So really, there's benefits to it, and it's cheaper. So it's cheaper, it doesn't get as hot. We're not using a ton of the computing power on it,
And the problem is, like, if you follow our instructions, you can make that product within 2 hours.
Yeah.
Not include the 3D printing because sometimes it takes a long time to do the 3D printing. I would start this project when I know nothing. I didn't know how to soldering thing. I know a little about circuits, but it was like 10 years ago when I was in high school. So, but now I feel like much comfortable to do the products, like what the issue we get, or some troubleshooting that we get into our, while we in our project, it helped me to learn a lot. So 2 hours, I would say 2 hours.
Yeah. Yeah, so lastly, we got some future ideas. We're working on all of them to some extent. So web camera integration is probably one of the coolest things to use this for. So if you have a web camera, most of the cheap web cameras have terrible motion detection. It detects, your cat walking around, or trees moving in the background, or bugs. And if you have outdoors, bug flies by. Oh, well, that's a lot of motion because it got like an inch away from the sensor. So integrating this with the web camera would be a great way to improve. Now you have a visualization of your house when you're gone. So this is just detecting, oh, there's motion, but you don't get to know what it is because you can't see it. Well, now this allows you to do that. Different radar sensors. So actually, in the last year or two, there have been a ton of new radar sensors in the market to get, and they're very cheap. They're between $1 and $5. So we're gonna possibly try some different ones. The one we're showing around worked very well. It works around 36 feet. I had some other ones. They seem to be more for gauging the speed of things. So cars going by, we don't need to know the speed of whatever it is. We just need to be sure that it's moving. So that it's just interesting to try the different options. And then phone integration. If we were to make an app for this, which we haven't had the time to do yet in the 2 months, an app would be great because we could control all the control settings that you have to push the buttons for on the control panel, and we could push that into an app so you can do it when you're away. It'd be an interesting idea. And that concludes our presentation. Welcoming any questions. Go ahead.
Thank you. I think you answered one of my questions at the very end. So are you planning to integrate with your phone, like using Bluetooth technology or something like that? Integrating this one with your phone, maybe you don't need to go here, you can simply see things.
Yeah. So with the app, we could have the status of the status of the control panel, making sure everything's idle, everything's good, and we could turn on and off the the buzzers, the loud noise. If it's scaring your pet, then you can turn it off or something like that.
I have a quick question.
Yeah, sure.
So you started saying that this is an intro course. Intro to, what's the name of this course?
In Introduction to Engineering Design.
Design.
For
Yeah.
freshmen.
Freshman. It's a 4-curricular course.
Yeah,
like
for
a-
any course.
Yeah.
I think my professor from our school already interviewed about that. How they create that course in our school. Try to get the student involved into the project early.
Yeah.
So it's an intro design course, right?
Yeah.
Intro
So
to
it looks like
engineering
you are
design.
touching so many things there. You have a Python there.
Mhm.
You have 3D printing things,
Yeah.
means SolidWorks or something like that. And of course you have the other circuit element and there are sensors type thing. So do they cover everything in class, or is kind of
No.
student come with their own skill and background?
There's nothing in class, so how they design in the beginning of the class, about 2 weeks or 3 weeks after we start the class, our professor gave us a chance to make whatever products we want to. So we have about 3 weeks to come up with the idea, and then we come talk to him. He gonna talk to us, he gonna tell us, okay, is that possible to make it within 2 months? And all the skill we have it here, we have to learn ourselves. He advised to us.
It looks like it's your special, your skill is the one displaying a big role here, not from the course, is that right?
No, so the course, it built a skill for us how to do troubleshooting. And then my professor opened a chance for us to learn what we want to learn. He tried to do about the circuits. So any product or project we want to do must related to circuit analysis. And then from that we can go further. So depend on how interested the project you want to do. My other classmates just do the regular one. And for us, we just decided to make much more, we put more effort to do with this one. Not every student or group in that class will do the same with us.
Can you go to your sensor slides, you show a couple of sensors there?
Yeah,
So
absolutely.
the hardware slide.
Yeah. Do you want the schematic or the
No,
picture?
that's slides, so the sensors.
Yes.
Are you using all of them? That what is that? There's something like a thermal or photoresist there. You have a use for that one?
This one?
Not
Or-
the one on the left. Yeah.
That one.
Addresses.
Yeah, so the LED is just a status indicator, and we can go up just a little more and see that, right?
Not the LED. I'm talking about the other one. The one.
Oh,
with the
yes, yes,
I think addresses.
the transistor, yeah. So that
Transistor. Okay, I see. Okay,
transistor,
then it's
yeah.
fine.
Real quick, that's just for the buzzer, because we were having issues with the power for the buzzer. We needed an amplifier, that's
That
what
is
that
the
does.
speaker, right? The one above that is.
That's a buzzer, yeah, buzzer, speaker, it's a loud buzzer. We wanted loudness over a nice chime, so we chose a buzzer.
Also, you're keeping your price low by using Raspberry Pi 3.
Yeah,
Actually, at that time, we have no choice because shortage of the supply, so that's one actually the used one too.
Oh, yes.
Yeah, we couldn't get the brand new one on time for our class and
So
try,
that
so we
will-
need to try before the class.
That will automatically increase the price by another $20-30.
yeah.
right?
But that's one.
Yeah, there's no reason to use the newest one, right? Go ahead. Thank you.
I know you mentioned market prices
Mhm.
overall, and I know that over the course of COVID pandemic, a lot of electronics have gone up in price.
Yeah.
Are you keeping track of the market prices over time for your project and can comment on how up to date your $68 number is and how
Yeah.
reliable
Before-
that can be through
So,
time?
yeah, those
Thank you.
price we update about 2.5 weeks ago. So when we did this one, we have different price when we buy the product in spring. So, some components is a little bit more expensive at that time compared with now.
Yeah.
But on the price we show here, that's it update about 2.5 weeks ago.
Yeah, the only thing that would have changed price, really, you would have seen a difference observable is the Pi. Now we've got the Pi used just to help us out because there's no reason to get the newest one. And actually, most recently, Raspberry Pi increased the price. That was a news article. So
Yeah, 2 days ago.
if you wanted to use the latest Pi, you would see a price increase. If you were to shop around for the computer, because there are so many that people buy and don't use and they want to sell, that's an option too.
But eventually they'll stop producing 3, right?
Yeah, so
That's a problem.
2 days ago, they announced the first time that they increased the price from $35 to $45, about a 25% of their products. So, but even that price increase, if you walk into Micro Center in Cambridge or in other place, if you don't order ahead of time, you may not be able to get the Raspberry Pi.
Yeah, it's just about getting it too. It's people pay the money for it. The Pi 3 is still a very good Pi. It's very powerful. It's from 2017. It's more than enough for what we needed.
So how about the radar? Sorry, go ahead. Okay, Simon.
Well, yeah, we'll come back.
Yes.
I have a few questions. One, the code that you use, did you put it on Git? Is it available for people to use?
Yeah, it's going on GitHub. We haven't published it yet because it's not completely finished. We want to upload a finished. I mean, we should upload it either way.
Okay.
It's going to be on Git.
Talking about
For
the
sure.
coding, so if you want to modify the half sensitive radar, we have room in the coding for you, because this project, how we make it different compared with the AI camera products, they use the picture image and they fit into the machine, like how the human look like, how the tree look like. But this one, we use the movement to decide, okay, should the box send a notification by the movement, like for example, if 2 seconds, the movement say continue for 2 seconds or 3 seconds,
Yes.
send me some notification. But if just 1 second, maybe just a mouse cross by, a tree
And you can
movement,
adjust that.
just
yeah.
ignore it. So, but you live in the city, you can adjust that. But if you live in town, you don't care. Sometimes you see deer, sometimes a lot of tree, so you can adjust like 3 seconds to send you notification.
And then I was just curious, do you have a means of storing the information that is recorded throughout the day? So if you wanted to, if it went off at some point and you wanted to go back to see what time that was, or do you have any
Yeah.
future ideas for that?
We could do it on an app. We could integrate it with the app. If you just wanted if we had 10 minutes to implement that, we could just write data recordings to the SD card. You can put in 64 gig SD card, costs like $10, and you can record, we can record all the measurements, and that would be that would be not so much data, because it's just a yes or a no. You know, it's not storing a ton of images, that would be a lot more consuming on the resources. So yeah, we could, and if we could use an app, which would give you a nice little graph or some kind of better solution than just recording raw data, so.
I just have one more question.
Yeah,
So
absolutely.
at the beginning, you talked about, you know, if you buy something off of Amazon, you don't know really who's looking at your data.
Exactly.
So this by itself, before you get to the phone app, doesn't need Wi-Fi, so it's completely off
Yeah,
grid.
yeah.
But if you integrate a phone app, then you have that issue
Yeah.
of someone, you know, snooping at your data or what have you. Have you considered that dilemma or that issue that you brought up in the beginning of having this stuff available for people, you know, on an app or something like that, where then it's potential to be hacked or looked at?
That's the reason why we started working this project again to improve our products. Like we want this to send a message to the phone, but we need to find a way that can secure our data information. But like at first, this one doesn't give any video, so your privacy less risk to be leaking. But then we need to keep the data itself when we send information. So that's something we need to improve.
Yeah, so it's all, just to add on to what Trin said, it's all local on the Pi until you get to phone notifications. Then you need some kind of API to send the notification to your phone. It's not just gonna go find your phone directly on the internet.
I'm sorry, you're gonna go first.
Yeah, it's
Oh,
yeah,
you're
yeah.
waiting for longer.
Thank you. So first, I like the design of this. I think it's a very nice design on the front. I'm curious
Thanks.
what the user can interact with the switch, what the buttons do, and what the display shows.
Yeah.
Like what messages would the user
So
see?
the Burn Original, we make a function like if you click a quick click, it can like turn on and turn off notification from the buzzer if that annoys you too much. And then if you click and hold it, if you do different notification, that Jason gonna set up about that one too when you hold the button.
Yeah, so you can, we actually programmed it so you tap the button, it does its function. You hold the button, it does another function, so we get more usability out of the button.
Yeah.
And there's two buttons in the switch, so the switch on the side acts as just a master switch. You shut that off, the thing shuts up. So, in case you're home, so you don't care.
Yeah,
Because
the
it's gonna go
button-
off a lot when you're home.
Yeah, the button also, like one button you can do like what we just said, and the other button you can just change how sensitive it is. Like if you set like horn for like 2 seconds, it's gonna change to 3 seconds sensitive.
Mm-hmm.
Or you can set it to 5 seconds sensitive, depending how long you're home. So you can always do that with the Raspberry Pi and the Python.
Yeah, and to answer your question about the screen, that actually, most of the code is actually about what to display on the screen, because when there's motion, we have it so that it says how long there's been motion, 1 second, 5 seconds, you know, it's a counter, it just keeps going. That's one of the threading loops that we have, it just keeps counting. We also have to determine whether to send a notification or not, because we don't want to annoy you. One of the buttons you press, just like Trin was just saying, you adjust how many seconds you want it to wait before it sends that notification. So just to confirm, you know, 5 seconds is a lot of movement, 1 second not so much. So yeah, that's the buttons do. The screen will tell you how severe the movement is, whether it's sent a notification, and that's an ongoing. The screen we can always adjust menus, and we've been doing that.
Like even if human just walk by, if the moment just happened for 1 second, and that's a human, so you should not be too concerned about that. But if like 5 seconds, the moment's still going, so something you need to care about. Might be something going on, or they want to do something with your house, that's why they stay that long. Yeah. And then the next one, I think that's here. You have any questions?
Oh yeah, I wanted to ask, so just quickly, the sensor communicating with the interface, that is a wireless communication between the two?
Yeah, wire. So we have the,
So, sorry.
yeah, we have transmitter, it's in the side.
Yeah, I'm just changing to the this guy here.
Well, I just wanted to ask, so this would be something, in terms of the range of it, I assume it's something that you would need to be relatively close to the sensor, and that you're not able to really be aware of anything going on if you're not in the home, like, so that you need to be close enough.
So
with the
that's
sensor.
why the future function for send notification to the phone that we need to improve.
Okay.
that. Yes, on
I know you mentioned using used components.
Yeah.
Does that affect your ability to produce something like this at scale? If you were to like go into a business and mass produce this, would you need to possibly adjust the sourcing of your parts to scale it?
Yeah, so for scaling real quick, we would not probably use a Raspberry Pi to scale this because the Raspberry Pi is a lot of computing power. This thing is not doing a ton of math. We used it mainly because of its versatility. We can adjust the code from it from our laptop over a wireless connection. We can pretty much work on this thing with it just plugged into the wall. And it's on Wi-Fi. Yeah, we would use all new parts if, you know, in the event that it is scaled up.
Okay.
So yeah.
What would you switch to besides Pi if you were to scale it?
Okay,
I'm just
so
curious.
first about the Pi, so originally we used it just, to be honest, the reason because I want to put something in my resume. I use Raspberry Pi, I can use Python. So that's why we make a decision to use Raspberry Pi.
Yeah, and you could use a less powerful but Wi-Fi for microcontroller like ESP32 is a good one that just came out. It's much less powerful, but it could still do take the functions. We'd have to turn down some of the times of the loops so that there's more time for everything to execute. It won't be that instant, but it'll still work. It's over Wi-Fi, so. But yeah, but on those you cannot program it right from Wi-Fi unless you jump through a lot of hoops, so you gotta plug it into your computer every time you program it. So yeah, it would be smaller if we used not a Raspberry Pi, but yeah.
I know this is like early in the design, but have you guys considered if you go forward and you want to market this product someday, would you want to sell it as like a plan that people can DIY it themselves, and if they have a printer and they,
Yeah.
you know, or have it like boxed and sold in the store? So one question, and two, like what do you know about this process of like what comes next, right? And how much testing you need to do and to get to that point that you can market it?
Yeah.
Yeah, so at this step right now, we can always do, like you said, the first one, like just make a kit for them with all the instructions so people can do. But once we get into the step of how we can secure the data to send notification to the phone, at that time we can sell like the full products, like finished products. You just need to buy it and set up into your house.
Yeah, and also just to add on that, we really have two choices. We can either just open source everything, let people build it themselves. You know, it's a fun project. We had a lot of fun with it, and we put our code up on GitHub and the STLs for the 3D printing. Those are public, and you know, the parts. Anyone could buy those, so we just list out all the parts. If we wanted to market it, we would keep those things secure and maybe you know, we'd have to scale up the 3D printing, we'd have to buy a ton of parts, the wires, we'd have to make it easy for someone to build. We could make it as a kit, like Trin said, or we could just build it ourselves and sell the actual product in its form that we have it now. That would probably be, you know, one of the more, it would be time consuming to polish it and make sure it's ready.
Probably didn't mention about multiple sensors, so about the one you can use indoor. I introduced the product to my friend, and they already like in the list to order because my friend have kids, and they say they want to have one sensor near the kitchen. So whenever they kid around the kitchens, they need to hear the noise, so they know that their kid over there, or they kid hide in some place they don't want to, like in the garage, or at night when the kid run away from their bedroom. So they want to know, but they don't want to use the cameras to lose their privacy.
Yeah.
So that's all the function that we can use with the indoor thing. And I think that interests people, and also it's gonna be engaged and motivate, especially for female, because female, when they touch those things, they feel like so much information they need to know. So we try to make it like as simple as we can, and send that to their product. They can create their own, how many sensors they want, where they want to put in the house, so they're in control.
Yeah, they're in control. That's a big factor. Just to quickly add, like with the oven, you can turn down the sensitivity quite a lot. So it's just looking around, in and around, like around the oven, so you know if someone's near it, you don't burn themselves. Like that's a big issue, especially for pets. It can detect pets. Anything with water or metal, it'll detect movement. so your pet doesn't walk on like the burner of a stove or something. Like there's actually a good number of implementations you could use. Just gotta think of what you might be useful for you and your house.
We would love to answer more.
Yeah, we can answer more,
outside,
yeah.
just because we're out of time right now.
Yeah, we have.
I have to
session
give
time.
our information and you can contact us with any question.
Thank you very much.
So if you have the feedback and please pass it to me.